Okay, so we know that this problem we can do with partial fractions because we can factor the denominator and rewrite it. And so the first thing we're going to do is we're going to factor the denominator. So let's rewrite this integral. So this is the integral of 1 over x minus 3 and x plus 7. Okay, so once we do that, then we know that this fraction, 1 over x minus 3 times x plus 7, this can be written as a over x minus 3 plus b over x plus 7. Okay, and so then we basically are looking for what these numbers a and b are. So what we do is we multiply both sides by the denominator, the common denominator, which is always the denominator over here. And so then what we end up getting is that 1 is equal to a times x plus 7 plus b times x minus 3. Now, there are two ways to find the values a and b. The easiest way, usually for the simple cases, is basically what you do is you zero out one of these and you solve for the other. The only problem with that is that it doesn't always work for the more complicated problems. But for now, let's just do that. So basically, let's say hypothetically we want to find what a is. So we want this factor right here to be 0. So we let x equal to whatever makes this factor 0, which is 3. Okay, so if x is equal to 3, then what we have is that 1 is equal to a times 3 plus 7 plus, and then this is b times 3 minus 3. So notice that this is equal to 0. And so what you can do is you can solve for a here. You would get that a is equal to 1 over 10. Because 7 plus 3 is 10, and then you divide by it. So that's what a is. And then you can do the same thing with, to zero out this one, you would say, okay, well, let's let x equal to negative 7. So if you do that, then what you get is that this one gets zeroed out. So you get 0 for this one. And then plus b times negative 7 minus 3. And I guess I should have put equals to 1, but I'll just put equals to 1 on this side. So equals to 1, that's this one right here. I just flip-flopped them. Okay, so anyways, then you get that b is equal to negative 1/10. And so having those two, then you can rewrite this fraction as, so this is going to be, let's rewrite the whole thing. So let's do this. Go up a little bit. Okay, so this is going to be the integral of, so this one right here, let me circle it. So a over x minus 3 is going to be, instead of a, I'm going to have 1/10. So 1 over 10 x minus 3. And then plus the integral of, and then let's do this one, b over x plus 7, but b is negative 1 over 10. So this is negative 1 over 10 times x plus 7. Okay. And then let's not forget our dx's, dx and dx. Okay. So let me rewrite this then. Now what we have is these aren't too bad to solve. This is 1 over 10, the integral of 1 over x minus 3 dx, and then minus 1 over 10, the integral of 1 over x plus 7 dx. And the antiderivative of each one of these is relatively simple. I'm not going to do substitution, but if you were to do substitution, you would let u be x minus 3, du equals dx. And so you would get that the antiderivative of this is natural log of the absolute value of x minus 3. With these, usually it's very easy to see what the antiderivative is. Okay, and then minus 1 over 10, and then the same thing with this one. This is going to be the natural log absolute value of x plus 7, and then plus some constant c. And that's it. Okay, so here we have another rational function, and we're going to use the method of partial fractions. Now, the first thing we're going to do is we're going to make sure that everything is factored completely. So the denominator has to be completely factored. And so notice that you can factor out an x from here, from the x squared plus x. And so then this is really equal to 3 dx over x times x plus 1 squared. Okay, now in this case, notice how we have a repeated factor, x plus 1. And so that means that when we factor, or when we convert, do the partial fraction decomposition, we're going to have a over x plus b over x plus 1 plus c over x plus 1 squared. Okay, so this is the form. Whenever you have a repeated factor, then you have to break it up in this form. And so, for example, if this was x plus 1 cubed, you would have x plus 1, and then a fraction with an x plus 1 squared, and then a fraction with x plus 1 cubed. Okay, so then the next step is to get rid of the denominators by multiplying everything by x times x plus 1 squared. So in that case, we would get that 3 is equal to a times x plus 1 squared plus b times x plus 1 plus c times x. Okay, now we're going to use the same method that we used in the previous problem, where we're going to start zeroing these out. So notice that both this term right here and this last term have an x, and so we can zero both of these out by letting x equal to 0. And if I let x equal to 0, what I would get is that 3 is equal to a times 0 plus 1 squared, and then notice that I would get 0 for both of these. And so what this means is that a is going to equal to 3. Okay, so that's good. And then notice that you can zero out both of these by letting x equal to negative 1. So let's do that. So if x equals to negative 1, then this one would get zeroed out. So let me write that out. So it's going to be 3 equals to 0 plus 0. So both this one and this one are going to get zeroed out. And then plus c times negative 1. So let's just make that minus c. So that means that c is going to equal to negative 3. Okay, now all we need to do is find out what b is. And so to do that, since I already know what a is and I know what c is, you can just pick any other number besides 0 and negative 1. How about How about let's pick x equals to positive 1. So any number that's, sort of simplest number you can think of. Then we would get 3 is equal to, here if x is equal to 1, this would be 1 plus 1 is 2, 2 squared is 4, times, at this point now, a is equal to 3, so this is going to be 12. Okay, and then plus 1 is 2 times 1, so this is going to be 2b. And then here we have 1, and then c I know is negative 3, so this is going to be minus 3. So then what I get is that b is equal to negative 3. Okay, so I've got a is 3, b is negative 3, and c is negative 3. So then I can decompose my my fraction in that way. So this one is 3, negative 3, negative 3. Sorry. Okay, so let's write this out then. So that means that this integral can be written as 3 different integrals. The first one would be 3 times the integral of dx over x. And then the next one is minus 3. So minus 3. I'm just going to take the constants on the outside. And minus 3 dx over x plus 1. And then again, minus 3, the integral of dx over x plus 1 squared. And so now what we're doing is we're focusing on these 3 integrals. So I'm going to move this all over here. Okay, now we're going to do this part a bit quick because this happens quite a bit, and so you should be comfortable doing these kinds of integrals quickly. This one, dx over x, we know that that is natural log of the absolute value of x. Okay, that one's easy. And then this one, same thing. You let u equal to x plus 1, du equals dx. And so, anytime you have just x plus or x minus a number, that's also going to be a natural log situation. So this is just negative 3 natural log x plus 1. Okay, now this one, same kind of thing. You let u equal to x plus 1, du equal dx. Now I'm writing this out, kind of quickly, but you really don't need to do the substitution explicitly when it's relatively simple. So this is going to be negative 3. And now this, you're sort of imagining, typically what I do is I say, you should be comfortable doing these kind of in your head. So what this turns into is 1 over u squared du. And so this you bring as u to the negative 2. So when you get the antiderivative of this, you add 1, divide by it. So this is going to be u to the negative 1 and then over negative 1. So that means that this is going to turn into a plus because of this negative. And then you're going to have, plus 3 over x plus 1, and then just to the 1 power. And then plus c. So that's it.